So here's a video on factoring trinomials of the form ax squared plus bx plus c, where a is not equal to 0. So I'm going to show you two examples that will help you understand the process. The first example is factoring 5x squared minus 6x plus 1. So to do this, we would like to find two integers, p and q, so that when we multiply p and q, we get 5 times 1, which is 5. And when we add p and q, we get the coefficient of x, which is minus 6. So to figure out p and q, if they exist, let's go over the factors of 5. So we can start with p being 1 and q being 5. Notice how 1 times 5 is 5. However, 1 plus 5 does not equal minus 6. So this pair of p and q does not work. So we move on to the next numbers on the list. The other factors of 5 are minus 1 and minus 5. Notice minus 1 times minus 5 equal 5. Not only that, if you add minus 1 and minus 5, you get negative 6. So this is the pair we are looking for. So with that said, now we have 5x squared minus 6x plus 1 can be factored as x minus 1, x minus 5. Notice minus 1 is p, minus 5 is q. And to make sure we have the correct factorization, meaning if we expand x minus 1, x minus 5, we wouldn't recover back 5x squared minus 6x plus 1. So to make sure that our factorization is correct, we take the leading coefficient 5, we multiply it up front, and divide it. Now we have 5 times x minus 1 over 5. X minus 1 is our factorization. Let's move on to another example. Let's factor 6x squared plus 5x minus 4. Here we want integers p and q that multiply to 6 times negative 4, which is negative 24. And we want p plus q to add up to 5. Going through the list, we see that if we pick p equals negative 3 and q equals 8, that will do the trick. Minus 3 times 8 is minus 24, and minus 3 plus 8 is 5. With that in mind, now we have 6x squared plus 5x minus 4. This is equal to x minus 3, x plus 8. And finally, we take that leading coefficient 6, we multiply it front and divide it by p and q. So the factorization becomes 6x minus 1/2 x plus 4/3.